This video goes over solving equations with variables on both sides. So your first step is to collect your terms with variables on one side of the equation and number terms on the other side. Your second step is to simplify both sides. Third step is to divide both sides by the number in front of the variable or the numerical coefficient. And then you're going to check your answer. So let's go through example 1 here. So first thing I'm going to do is collect my terms with variables on one side. So I'm going to move 3x over and change the sign. And I'm also going to move my number over to the right-hand side. So now I've got 5x minus 3x plus 5x, and then minus 2 plus 8. The second thing that I'm going to do is I'm going to simplify by collecting like terms. So I'm left with 2x equals 6, and then I'm going to divide both sides by 2, which leaves me with x equals 3. Now, in order to check and see if my solution is correct, I can look at the left side of my original equation and the right side of my original equation. My original left side is 5x minus 8, and my original right side is 3x minus 2. I think the answer is 3, so I'm going to put in 3 for x and evaluate both expressions. 15 minus 8 gives me 7 on the left-hand side, and 9 minus 2 gives me 7 on the right-hand side. So then I can conclude that the left side equals the right side. Therefore, x equals 3 is the correct solution. Let's try another example. So the first thing I'm going to do is move my variables to one side. So move 5m to the left. And I'm going to move my numbers to the right-hand side. So I'm left with minus 5m plus 4m equals minus 3 minus 2. Remembering that whenever you move something over the equal sign, you always need to change the sign. So on the left-hand side, I'm left with minus m equals minus 5. Dividing both sides by minus 1, which is the number in front of the m, I'm left with m equals 5. Now I'm going to double check by substituting into my original equation. What I did in example A, this is a formal check. Here I'm going to do an informal check in B. So 2 plus 4 times 5 would be 22. Putting m equals 5 into my right-hand side, minus 3 plus 5 times 5. So minus 3 plus 25 is 22, which is the same. So I know my answer is correct. Let's do another example down here. So here I only need to move my 5 minus 5x onto the other side. So now I've got plus 5x plus 15x minus 7x equals minus 52. Collecting those like terms gives me 13x equals minus 52. And now I can divide both sides by 13, which is going to give me x equals minus 4 as my final answer. One more. Now I've got 7t. I need to bring that over to the left-hand side. So I've got minus 7t plus 3t equals minus 12. Leaves me with 4t, or minus 4t on the left-hand side, minus 12 on the right, and then I can divide both sides by minus 4, which leaves me with t equals 3. Example 2 is going to ask us to solve and check. So this means to do a formal check using the left side, right side table that we did up here in example 1. So let's start by moving all our variables onto one side, all our numbers onto the other side. So I've got plus 3x plus x equals 4 minus 12, which simplifies to 4x equals -8. Dividing both sides by 4 leaves us with x equals -2. That is my solve part. The next thing that I'm going to do is check my answer. So I'm going to draw a table that has the left side and the right side. My left side from the original equation is x plus 12. My right side from the original equation is -3x plus 4. I think x is equal to -2, so that's the value that I'm going to sub in. And then I'm going to evaluate both sides. So when x is equal to -2, my left side is 10. When x is equal to -2, my right-hand side is also 10. So my left side is equal to my right side. Therefore, x is equal to -2. This is the part that is considered to be a check. Example 2b. Same way that we start, moving our variables to one side, moving our numbers to the other side. So I've got plus 4x plus 2x is equal to 13 plus 11. Combining our like terms here, 6x equals 24. Dividing both sides by 6 gives me x equals 4. Now I have the left side and the right side. My left side of the original equation is 2x minus 11. My right-hand side is 13 minus 4x. Always make sure you're copying the equation down correctly. Now I think x is equal to 4, so I'm going to plug that in here. My left side when I do that is equal to -3. My right-hand side when I do that is also equal to -3. So my left side is equal to the right side, which means that x equals 4 is correct. Here we've got a little bit more complicated question. We're starting off with an expression that has two variables. But I also have some information. I know that I'm looking for Q when I have a value for P. So my first step is going to be to substitute in P equals 20. So now I've got 60 times 20 plus 25Q equals 2400. And now I can evaluate this expression. Now it looks like something that I've solved before. So I'm going to take my 1200, move it over to the right-hand side and change the sign. So 2400 minus 1200. Now I'm left with 25Q equals 1200. Then I'm going to divide both sides by 25, which is going to give me, let's see, 1200 divided by 25 gives me a total of 48. In this example, a candy store is making up a mixture of chocolate-coated almonds and chocolate-coated raisins. The almonds cost $30 per kilogram, and the raisins cost $10 per kilogram. And I know that the final value of the mixture is 150. So in order to write an equation, the first thing that we need to do is define our variables. So let's let A represent the amount in kilograms of almonds. So I use A for almonds. And let's let R represent the amount in kilograms of raisins. So I know that the total mixture has to equal $150. That's my total, goes on the right-hand side. The cost for the almonds is $30 per kilogram times the amount of kilograms, plus $10 per kilogram times the amount of raisins that I have. B asks us to solve the equation for the required mass of almonds. Okay. I know that from the question above that the mix contains 7.5 kilograms of raisins. So that means that R equals 7.5, and I'm looking for A. So in my equation, I'll rewrite it down here. I am going to substitute in my value of 7.5 for R, because what I want to know is if I have 7.5 kilograms of raisins and it cost me $150, how many kilograms of chocolate-coated almonds do I have? So here I've got 30A plus 75 equals 150. I'm going to move my 75 over and change the sign. So I've got 30A equals 150 minus 75. Oops, 30A equals 75. And then in order to figure out what A is, I'm going to divide both sides by 30. So dividing both sides by 30, using my calculator here, I've got 75 divided by 30, which is going to give me 2.5. So that means I have 2.5 kilograms of almonds.